Okay, let's go ahead and get started. So this is the second webinar of 3 for today. And we are going to cover OpenNebula and LINBIT SDS and how believe we're going to see how to deploy that. On the line today, presenting is Jim Freeman. He's a cloud solution architecture at OpenNebula. He's got extensive experience in cloud computing, along with working with the vendors and end users. Additionally, we have Michael, and he is the customer success manager at OpenNebula. He's responsible for the United States and Europe. We've also got Renee again. He was on the previous webinar. So if you're there, you already know about Renee, but he's one of our core developers for LINSTOR and the surrounding plugins. He's been with LINBIT since 2017, I believe. And we also have Yusuf, who is a solutions architect over in Europe. He's been with LINBIT for several years and is also responsible for the LINBIT Lincast that we do monthly. So do you want to go ahead and begin, Jim?
Actually, so this is Michael here. I'm gonna kick off the presentation. Just to give everybody a little bit of an overview of OpenNebula and our organization, what we're doing, and then Jim is going to follow up with a little bit more of a deep dive. As Brian pointed out, I'm the customer success and account manager at OpenNebula. First of all, OpenNebula, and first and foremost, is an open source company. I think the focus of what we've been doing for over the large part of a decade and a half is developing open source software. Our OpenNebula project began back in 2005. And through the development and evolution of the project and the software, we've been really focused on providing this open source solution. However, in addition to managing and directing the software development, we also provide organizations with enterprise support and professional services for those organizations that are looking for a bolstered and supported backing from our organization. We are headquartered in Madrid, in Spain. We also have offices in the US, as well as in the Czech Republic. Okay, so this here is just a slide to kind of highlight who's using OpenNebula. As I pointed out, from the standpoint of it being an open source software, there are actually over 5,000 active OpenNebula clouds currently running. From the standpoint, a measure of, scalability, one of the largest ones of which we're, specifically aware of is running across 16 different data centers and has, over 300,000 cores. Okay, and then down below, I think we just wanted to highlight kind of, the broad spectrum of users of OpenNebula. OpenNebula serves across industries, and here you can basically see, across the users and customers of ours, that it is essentially not only production ready, but used across many different enterprises. Okay, and so one of the things that we've been focusing on over the, I'd say over at least the past 2 years has really been broadening OpenNebula's reach and essentially making its way into the edge cloud computing space. Back in 2019, we received innovation commission from the European Commission to build out the capabilities of extending OpenNebula's capabilities and reaching the edge, right? So we understand that, the paradigm of being able to provide low latency capabilities for users and applications and organizations, the centralized cloud model is no longer just a one and done approach. So with our One Edge project, and you can take a look at this webpage, oneedge.io, you can learn a little bit more about the developments that we've introduced into OpenNebula in reaching the edge. And one of the things you'll see that with our OpenNebula 6.0 release, which we just released a few weeks ago, there are many capabilities addressing the edge, our edge capability. Excuse me. There are, one second. So Jim's going to jump into some additional hold on just one moment. Oh, all right, perfect. So in addition to the open source software, we provide subscriptions to our customers. And our subscriptions are the basis for essentially providing organizations with access to our enterprise edition, which provides customers with now a hardened version of a more hardened version of our software. It provides bug fixes, software patches, and minor enhancements. And it also provides LTS releases, long-term supported releases. So right now with our OpenNebula 6.0 release, we are also supporting a long-term release, a long-term version of our previous 5.12. So that version is available for and supported for, for the essentially 2 more years. Our subscriptions also provide, like I said, SLA enterprise support, whether you need 9 to 5 business hours or 24/7 support. They provide access as well to our knowledge base and enterprise tools that allow access to step-by-step guides, additional know-how tools, as well as providing enterprise tools for simplifying and automating some of the management of your cloud. And they also, our subscriptions provide access to professional services that our engineering teams make available as well. So that's just a high level look of some of the offerings that we provide as an organization in support of OpenNebula. Now, I think Jim's going to take over and dive in a little bit more to our open architecture and the storage support.
Thank you, Michael. Hi, everyone. My name is Jim Freeman. I'm a cloud solutions architect at OpenNebula. Just going to spend a couple of minutes today talking about OpenNebula's architecture and again, the support for all the different storage solutions we have. So for anyone who's just new to or starting out with OpenNebula, just want to cover some basic information about the product. As Michael mentioned, OpenNebula is an open source cloud management platform. It allows you to create enterprise clouds and run any kind of workload on all different kind of infrastructures. Whether this is in your own data center or on the edge, as Michael was mentioning. In 6.0, we have the ability to dynamically expand resources by consuming popular cloud and bare metal providers. And what this does, this automatically configures hosts there. Obviously, if you still want to use servers in your data center, absolutely fine as well. In this slide, we have a high-level view of the OpenNebula architecture. You can see all the different types of virtualization that we do support. We obviously have VMware, vCenter, support for VMs in KVM, Firecracker micro VMs, and LXC system containers. All of these are managed by a single OpenNebula instance that has a Sunstone graphical user interface. We integrate with a lot of third-party tools as well. Just one example is Docker Hub. This allows you to download images directly from Docker Hub repo and map the Docker container directly into a micro VM on our Firecracker virtualization. So a couple of weeks back, we released our latest version of OpenNebula 6.0. We do have a dedicated session on that tomorrow. So I'm just going to summarize a couple of bits and pieces here. The session is at 5 p.m. Central European time or 8 a.m. Pacific time. So feel free to tune into that to get a bit more of a deep dive on them. So perhaps the biggest feature in 6.0 is our new FireEdge UI. So this is what allows you to automatically provision these clusters on AWS or Equinix Metal through an intuitive interface. We've released last week with AWS and Equinix, but our plan is to add a lot more of these drivers in the future. This brings this whole cluster as a service functionality. And in the future, we hope to integrate with lots more bare metal providers, cloud providers, and everyone else. So when you build an edge cluster in OpenNebula through our FireEdge interface, this automatically uses our new edge cloud architecture. This is a really lightweight, hyper-converged architecture that's powerful enough to run any workload you have with optimal performance. It always uses the best placed storage backend, for example, which really improves performance. Again, there's a deep dive session into this in tomorrow's session that will go more into that. Talking of storage, let's move on to the different types of storage architecture that is available. OpenNebula has been designed to work with any kind of storage backend, really, whether you're using some kind of object storage or block devices that you present to hypervisors. And we do have some really strong integrations with vendors as well, such as LINBIT here today. And lastly, LINBIT have created a dedicated storage driver to use for OpenNebula. It's available on GitHub, as you can see on the screen. At this point, I'd like to hand over to Yusuf from LINBIT, who's going to provide more information and perform a demonstration on how LINBIT and OpenNebula can work together. Thank you.
Thank you, Jim. Let me share my screen quickly. Okay, I guess this is it. All right, so hello everyone, Yusuf here. So in the previous webinar, Rini explained how LINSTOR actually works, but for who didn't attend to that meeting, so I just want to give you an overview about how LINSTOR is working. So as you can see here, we have satellites that are installed on each node. And then the controller is independent and can be anywhere in the cluster or maybe out of the cluster. That depends on your setup, your preference. And the LINSTOR has an API library and driver library and the CLI for the interaction interfaces. And OpenNebula plugin connects the OpenNebula with the LINSTOR controller. And within the LINSTOR, you have resources, and those resource volumes in LINSTOR is reflected as a backend disk in OpenNebula, VMs or other things. So, and with this replicated resources within LINSTOR, shared between the nodes, gives you the power of live migration in the cluster. And LINBIT SDS also supports the latest OpenNebula version 6, which is the Mutara perfectly. So, and one more thing that I want to give you the information between the LINBIT and OpenNebula. So both companies are working for open source community, and we have been around like more than 20 years, and they have been around, I don't know, 15, 16, right, Michael? I think it's 16, right? More than 16 years. And both systems are capable of working in many Linux distributions, and both systems are focused on many different cases. And LINBIT SDS is, because of the DRBD, is especially tailored for high performance and low latency environments, but we are also good at the edge computing or many other cases because of the LINSTOR's flexibility. And the OpenNebula is simple, efficient, and it works great. And same goes for the LINBIT SDS. We have like millions of installations with our software in the community. And both systems can give you the power of no vendor lock-in. So this is really important these days, especially people are suffering from budget and so many things. So this will give you a really great power in terms of talking with the vendors if you want to buy a couple of new ones. Yeah, so this is pretty much the common things between the LINBIT and OpenNebula. And now I will hand over to René, and he will show us how LINBIT SDS, aka LINSTOR, underneath the software, perfectly matches with the OpenNebula environment. How do we do the integration? How the driver works? And maybe if he left some time, and he can show us some live migrations and many other things in the demo. René, it's on you now.
Okay, thank you.
You're welcome.
So, hello, everyone, again, who is back again. And hello to everyone new. So we'll share my screen. So what I will show you here now is how to install the LINSTOR plugin or integrate LINSTOR into OpenNebula. What I have here is an already set up LINSTOR cluster with 3 nodes. You can see the windows, but we will probably mostly just be in the node 1.6 plugin 140, because this is the node which has the LINSTOR controller and the OpenNebula frontend installed. What we will start with is we will add 2 resource groups. To LINSTOR. These LINSTOR groups will then be basically mapped to data stores in OpenNebula. So we will have one system data store and one normal data store for images. And we will create now the corresponding resource groups for them now in LINSTOR. And I will call them data resource group, and it has the name data resource group. It will have a place count of 2. And it will use
2 represents the 2 replica, right?
Yeah, it has 2 diskful replicas.
2 diskful replicas.
Yeah. And yeah, we'll just use all. Oh no, I have to add to see which storage pools we have. So we have one thin storage pool, and we will use this one. See, okay, we have one data resource group, place count 2, and uses storage pool thin. And now we will add another one, which uses the same storage pool for the system data store. Let's call it system resource group. And we'll also have to create volume groups for those resource groups. And now we are set up. So this is from the LINSTOR side. And now we will add our plugin. If you're a customer from LINBIT, you can just install it via apt-get from the LINBIT repositories. It's called add-on LINSTOR. And yeah, now the scripts are in place, but to make OpenNebula aware of, we have to configure OpenNebula. We have described this part in our LINSTOR users guide, which you can find on the LINBIT website. And I guess Yusuf can also post the link in the chat to the OpenNebula section.
Yeah,
and basically it's just following steps there. So we have to start with editing the OpenNebula 1D config file. And this is a mistake which is often made. There are two MED sections here, the TM MED and the data store MED. In the TM MED, you just have to add LINSTOR here at the end. But in the data store MED, you have to add it twice. So first for the data store part with the -d argument and -s for the system data store. Because if you miss one or another, it won't work for those types of data stores. So always put them twice in the data store MED. And once this is done, you can just go to the end of the file and copy paste our data store, our TM-MED configuration and DS-MED configuration for LINSTOR. Then save the file. And you are good to restart OpenNebula. take a few seconds. What will be next is, so it's already done. So let's see if it's still running and I didn't make any typos. So it's running. We can probably already see here, yeah, it's mentioned LINSTOR. So it seems to work. At least didn't crash or anything. Sorry. And now what you have to do is I can show you now in the 6 plugin 14 in the OpenNebula front end. So right now we have the default data stores from OpenNebula. And what we're doing now is add here the ones we will use for LINSTOR. So I've already prepared 2 files here, which contain the basic configuration for them. You can also add them plain by create a new data store here and add all those details here, but it's easier from the file, in my opinion. Which the files you can also copy paste from our LINSTOR guide. And so all you have to do here is now change the LINSTOR resource group name, because I called them system resource group. And yeah, just a quick explanation. So the name will be the name of the data store in OpenNebula. So we will call it LINSTOR underline system underline data store. It uses our driver, the TMAT LINSTOR. It is type system data store. And the next one is already a LINSTOR property, which just tells it what resource group to use. And the bridge list is a common property from OpenNebula, which should be a list of all nodes which have access to the storage. So in our case, all of them. But it could be that you have the OpenNebula front end on some node with no storage access, and then you would leave that out here, or compute nodes on other stuff. So I'll just check. Yeah, system RG and system RG. And now use one data store, create, and the file. And we will now have a new data store with the ID 100. You can also see it here. And it has a few default attributes and from our inherited from our driver definition, the bridge list, and which resource group it uses. You can also change that later here if you made a mistake or want to, at one point, switch to another resource group. And we do the same now for the normal image data store. So again, the name, it will be called LINSTOR data store. It uses the DSMAT driver LINSTOR and the TMAT driver LINSTOR. It is of type image data store. It is disk type block, because that's what LINSTOR is providing, block devices. And we called it data RG in LINSTOR. And compatible sys data store is a list of, yeah, as it says, compatible system data stores. So our LINSTOR driver can work with the default system driver from OpenNebula and with our own, of course, and you have to specify the IDs of those here. Otherwise, the scheduler won't find any system data stores to work with and usually don't fail because it couldn't schedule the virtual machines then. And the bridge list is the same as before. And then, just as before, just one data store create and store. And we will have another driver, data store with ID 101. And now we could just use them. So easy thing to try is here usually to just go in the marketplace for OpenNebula. I like to pick Alpine Linux images because they are small. Then import it to the data store and pick the LINSTOR data store. Before we do that, I will show you right now we have nothing in our LINSTOR cluster. So we have no resources there, no resource definitions, and of course, no volumes. Oops, volume list. And now we will import that Alpine Linux from the marketplace. And in the background, you'll see now we have a new resource in LINSTOR, which is called OpenNebula Image 1. This one is the image ID from OpenNebula. The volume is the resource and also volume is on node 140 and 141 and is currently used in 140. And when I redo the command now, it will be unused. It was in use before because OpenNebula downloaded the image and wrote the data into the LINSTOR volume. And it is finished now. And yeah, you would also have seen this in the image view because it would be yellow and not status ready until it is finished writing all the data into it. So now you see Alpine image is only not even 60 megabyte large. And we also got a template with it. I'm not the OpenNebula expert, but I guess Michael and Jim will show you tomorrow everything in OpenNebula. But we will just instantiate this Alpine image into a new, well, let's create 3 instances. I'm adventurous here. Pick a network interface. Default. No, I don't need a security group. And yeah, you can select here if you want to put it on a specific host, but usually it will just pick the right one for you with the lowest CPU usage. And yeah, you can also here specify a data store in which the system data store runs. I think it usually, whenever I set up one OpenNebula cluster with LINSTOR, it will always pick then the LINSTOR system data store, which has the small advantage that the context image for the virtual machine will be stored there. And yeah, let's instantiate. So you see now, started. It's in pending, and yeah, and now OpenNebula started to create, or the plugin started to create resources for it. So you see we got it right in the middle of it, so there are nodes still connecting. But a few moments later, if everything is set up and copied and getting ready, so you see now that we have virtual machine 3 is running on 142 because it's in use here, and VM4 is on 141, and VM5 was 140, so it distributed it evenly. You can also see this here in the list. And can open the VNC connection here. And yeah, we have a running virtual machine. So, and to do a quick demonstration of, oh, okay. This is something I want to see. Okay, so this booted fine. So I will cut here in the middle of the login and live migrate this one to another host. So we are running right now on 141, and I will place it on 140. And what's running in the background here now is that, so we picked number 4. So LINSTOR will, or the LINSTOR, the OpenNebula plugin will now allow true primaries, which is essential for live migration, and basically the only case we really encourage it to do. So allow 2 primaries means that 2 nodes can at the same time do primary or have a resource, a DBD resource as primary, and KVM or KEMU is responsible to only write locked to the volume. And yeah, I think it's already done because we're already in use on 140. And if I go back here, you see the VM didn't shut down, just canceled my login because of a timeout of the 60 seconds. I didn't enter any user password, but it's still running. Yeah. And what else can I show you? The LINSTOR plugin usually tries to log any errors into the virtual machine log file, and has a more detailed log in on the systemd journal and in the unit OpenNebula. So you can see here that, for example, here this is the part of the live migration. So you get the pre-migrate script is called that it wants from node 16 plugin 140 to 140. Then here's some info from the plugin which is running in the background, and then the post-migrate step. And yeah, also errors would be shown here. So yeah. And the LINSTOR OpenNebula driver basically supports all functions of what OpenNebula provides. So we can resize the disks. So let's say we want now a 1 GB volume. running now the disk resize. So yeah, I didn't show you before, but the other virtual machines have a size of 256, and I resized the virtual machine 4, and it's now 1 GB. I can also log in into this one and see if it picked up. Okay. Something I didn't want to see. It seems it didn't work from, not completely go through. So it did resize in LINSTOR, but it seems there was some problem. Which you can't see now, but OpenNebula still thinks it's only 265, but it's actually not. So I'm not sure what's the problem here. So yeah, this concludes my demonstration.
Thank you, René.
We can switch back
great.
to the Q&A.
Michael, I think we have a question.
Yes, no, so I've seen that some questions have come through the Q&A portion of the Zoom, but also here in the chat, there was a question posed by Angel. It was pretty kind of straightforward, saying, why choose OpenNebula over other solutions such as OpenStack? What are your strengths? So, I think really at a high level, OpenNebula, has been developed and really been focused on providing a solution that's based on simplicity and flexibility. Many comparisons in the industry, do compare OpenNebula with OpenStack, just as a simple kind of logical comparison. I think one of the standout points here is that OpenNebula it's a single distribution, right? So you don't need to have multiple components all working together in sync. OpenNebula is really, like I said, a single distribution. And then, kind of standing those products together and comparing OpenNebula to other products on the market, the idea is really that it's a simple solution that can be managed, by a very small team, right? So whether it's a single administrator, from a user perspective, the solution that we provide is really based on its simplicity. And then just one last thing I would say is, I think as we look, and perhaps you take a look at tomorrow's session, as we overview OpenNebula 6.0, I think the edge capability that we're delivering with this OpenNebula 6.0 is really innovative, right? So essentially allowing you to create an enterprise cloud, utilizing any application, whether they're container workloads, VMs, or Kubernetes clusters, and then essentially deploying and utilizing any infrastructure, whether it's on premises, hosted resources, or resources that are provided by public cloud providers, as well as edge resource providers. And then really having that at your fingertips to kind of deploy and manage on demand is something that I don't think other solutions are doing. So that's just really a quick high level overview. Hopefully that helps. If you have questions, certainly reach back out.
Thank you, Michael. One more question from one attendee, and I think I will answer that live. So the question was, what is the advantage of having the system data store on LINSTOR? So it's basic. So the answer is, so with having the context images on LINSTOR, you can restart the VM even if your OpenNebula controller is down. And since the context image is also stored on multiple nodes, so you have this power in your cluster. And also it should perform better because the violet images are also stored there. And yeah, that will help you. And one more question we have, I think Renee can answer that. And it says if OpenNebula and LINSTOR combination, please support team provisioning volumes. Yes, we do, and volume expansion and volume shrinking. I know volume expansion, but how about volume shrinking? I don't know yet.
No, I'm not sure right now, but I think we didn't support it, but we had a discussion lately, but I'm not sure if it's already released to allow shrinking, because there are some file systems which doesn't support shrinking, and so from the beginning we said we rather wouldn't support it at all, because users might shoot themselves in their foot if they try to shrink and it starts from below or from the top, and then something goes wrong and your data is broken. But I think we have a discussion that we might allow it if the user knows what he does. But I'm not sure if it's released yet.
I think that's it, right, Brian? We have like 3 more minutes, right?
Yeah, we're coming to the end of it here. So thank you all for attending. We appreciate it. I believe these slides and the recording of the session will be sent out once we're done with the OpenNebula LINBIT days here. The next webinar we have is coming up in about 12 minutes, and that will be with Supermicro, going over some hardware that you might use in deploying an OpenNebula and LINBIT cluster. Tomorrow we have 3 more sessions. As mentioned before, we have a deep dive into OpenNebula 6. We've got a customer success story where we're going to talk, Yusuf and I will talk to Cohen from Procolix, and go into their solution. And then finally, we'll wrap up with the developer Q&A, where you guys can ask the developers all the hard questions you have. So thank you for attending, and hopefully see you at the next one. Bye.